Hello everyone, welcome to my channel. Today we'll solve Leetcode problem number 399, evaluate division. Problem statement is you are given equations in the format of a divided by b equals to k, where a and b are variables represented as strings and k is the real number. Given some queries, return the answers. If the answer doesn't exist, return minus 1.0. The input is always valid. You may assume that evaluating the queries will result in no division by 0. And there is no contradiction. Few examples are given. So in the first example, we have given a divided by b equals to 2.0 and b divided by c equals to 3.0. And here is the list of queries. So we have to find out the value of a divided by c, b divided by a divided by e, a divided by a, and x divided by x. Similarly, in the second example, we have given a divided by b equals to 1.5, b divided by c equals to 2.5, and bc divided by cd equals to 5.0. And we have to find out the value of a divided by c divided by b, bc divided by cd, and cd divided by bc. So a divided by b equals to 1.5. Then what is the value of b divided by a? So it's 1 divided by 1.5. So we can represent these equations as a graph. So here, so a divided by b is 1.5. So I have added one edge from a to b, the value 1.5. So similarly added any reverse edge like b to a, its value is 1 divided by 1.5. And b divided by c is 2.5. So added edge from b to c with the value 2.5. Similarly added reverse edge from c to b, it's 1 divided by 2.5. And also given bc divided by cd is 5, and added reverse edge from cd to bc with value 1 divided by 5. So first we have to find out the value of a divided by c. So we can write it down like a divided by c equals to a divided by b into b divided by c. So basically we'll start from the starting node and we'll do the DFS. So in the first example, a divided by c, so starting node is a, so we'll start from a. So now we'll go to the, so we have only one neighbor, so we'll go to the b. Now from b we'll go to the c. Now reach to the end node c, so we'll just multiply the edges. So in this case 1.5 into 2.5. Now let's look into the second example, second equation. So it's b to c. So we'll start from b. And now we'll go to the its neighbor. So one is b to a, another is b to c. So if we start, if we go first b to a, so b to a is 1 divided by 1.5. Then from a you can go to the b. So already visited b, so we'll go to the next neighbor. So next neighbor is c. So now we reached to the end node, so we'll return this value. So we have only one edge, so we'll return 2.5. So basically we have to perform the DFS. Okay, let's then write down the code in Java. So here first we'll create first we'll construct the Java construct the graph. So here we'll use the adjacency list. So first is the string, and so here also we have to store the weight of each node. So I'll create one edge class. So string 2, and its weight is double, so double. Create a constructor to initialize it. Okay, so now it's a list of edges. So adjacency list equals to new asthma. Okay, now the equations count, so dot length, will iterate over all the equations. So from is the, so from equations, so it's a list of leads. So I will get the one equation from here. So the first item, the from node, and second item is the to node, one. So first we'll put if absent new array list, we'll add the to node. Now we'll get the from, and then we'll add new edge. It's to node and weight, it's a value size. Similarly, add another edge from to from. So here we'll get the 2, and here it's from, and in this case the value is 1 divided by. Now after this, so it will create the graph. Now we'll declare one result array, double new double. So it would be the size of the result array, so it's the list of the size of queries. So it's size equals to queries dot size. So this is the size of the. Now loop over each query. Plus. So here so I'll create one method which will do the DFS. So return the value. So need the starting node and to node from 2, and also need the adjacency list. And also the visited set. Okay, so from here we'll call the DFS. So here we'll give queries dot get I dot get 0. So this is our from, and then we'll pass to node. So this is the to node, and then we'll pass our adjacency list, and one empty has set. So let's create two separate variable from and to. Now here we'll pass those two, from and to. Now before calling, just check if both node exist. So I'll check adjacency dot contents key from. If key doesn't exist, from, or the two also doesn't exist, so in that case we'll directly assign to -1.0. It's key 2, then we'll return result I equals to -1, else we'll call our DFS, and then at last we'll return a result array. Okay, so now here, so here we'll check if from and to both are same. So it's a string, so you have to call the equals method to check the equality. So in that case we'll return 1, otherwise we'll mark the current node as visited, and then loop over all the edges of the current node. So first we'll check if the two node is already visited. So if visited dot contents dot to node, so in that case we'll continue. Otherwise we'll call the DFS with the new to node, so new from node. Store the result. Now if the result is not equals to -1, so in that case we'll return result into the weight from to 2, so that is the age dot weight. If we are here, that means we didn't find any such path, so we'll return -1. So let's run the code. So it's okay, and now let's submit it. So our solution is accepted, and you can see the runtime 1 millisecond faster than 71% of Java Online submissions. Yeah, so that's it for today. Thanks for watching. If you have any comments or feedback, just let me know in the comment section below. Thank you.